All right, this is section 4.6, which is graphing systems of linear inequalities in two variables. So recall that we graphed linear inequalities of two variables at the end of chapter 3. So that was section 3.7. Oh. And we're going to do it now with a system of inequalities. That is, we might have two, and you can get 3 or 4, but we'll stick to something pretty small, like a system of two inequalities. And the graphing part is very similar to in chapter 3.7, but instead of just having one inequality, now we have two, and we have kind of overlapping solution areas. And then the solution to the system is the intersection of the solutions to each inequality. So what that means is we're going to graph these, and then the overlap of the solutions is the solution to this system. So let's take a look at some of these and see what that looks like. I might have a system that looks like this. 2x plus 5y is less than or equal to 10. And let's say we have y is greater than 1/2 x plus 2. So I'm going to graph it. We'll take a look at what each of these inequalities looks like. The top one I should be able to graph using the intercept method. If x is 0, that is eliminated. Divide each side by 5 and I get y is 2. So I have a point here. If y is 0, I have x is 10, divide each side by 2, and I get x is 5. Right? And I'm just finding 2 points and then graphing the line. The line is a solid line because this is an inclusive inequality, and so I have this solid straight line here. Right? And that's just the graph of my first line. Now I want to check a point, 0, 0, because it's easy. If I have 0 plus 0, that gives me 0 is less than or equal to 10. That's true. And so my solution for this line is down here. And I don't want to go too crazy, especially if I'm on paper with pencil. If I make this just black, then I have to still draw another line, and I have this big black spot where I can't say, well, this is my solution area, this is not, because then it's just one big black ugly area. So just shade it lightly, right? And then we'll graph this other line. And I'm going to graph this other line in perhaps orange. But this is in slope-intercept form, so I have this same point. My intercept is 2. So I'm here, right? And I have a slope of 1/2, so that means I go up 1 over 2. And this one is a dotted line because it's a strict greater than. And so I have a dotted line there, right? Now again, I have to find my solution area, so I'm going to check 0, 0. And if 0, 0 is a solution, then the solution to my orange dotted line is just everything down in this region. So I'll check it. Plug in 0, 0, gives me 0 is greater than 0 plus 2, or 2, but that's false. And so my solution area is not down below this line, but it's above it. And so my solution area for the orange line is here, right? And so the final solution is the double shaded area. And we can see that that happens above the dotted line here, but below the solid line here. And so now if you want, you can go crazy. Probably not too crazy, because if you go too dark and then go up your dotted line, it's hard to tell that it's a dotted line. But the solution is this little triangular piece here that goes off, forever in that direction and in that direction. So that is my solution area for this system. All right, let's take a look at a couple of these. Here's another one, 3x minus 2y is less than 6. And 4x plus 5y is less than or equal to negative 20. All right, so again, we're going to graph this. And again, with graphing, it's always easier to do it with a pencil and paper. With shading is terrible with the expo marker on these boards, but let's take a look at the top one. If x is equal to 0, I divide each side by negative 2 to get y is negative 3. And then if y is 0, then I divide each side by 3 to get x is 2. This should be down here. Y is negative 3 is down there. And so I have this line which is dotted because it's a strict inequality. Right. Check a point, 0, 0. 0 is less than 6 is true. And so for now my solution area is above that line, somewhere in this area. Taking a look at the other equation, this one I can also do by finding the intercepts. If x is 0, divide each side by 5 and y is negative 4. So here, perhaps. If y is 0, divide each side by 4 and x is negative 5. So here. This one is a solid line. Something like that. And again, I'll check 0, 0. I can always check 0, 0 unless my line goes through it. So that's my default go-to. Plugging in zeros, I have 0 is less than negative 20, which is false. And so it's not up here above the blue line, but it's down here below it. And then once again, this double shaded region is my solution. That is below this blue line, but above this dotted black line. And so again, it's this triangular region over here. And again, this graph, I'm looking at the graph on the screen here. I'm looking at it on the, it looks terrible. Look below, I just did the example 2 down. It's graphed much more visually appealing. Go down and look at those for a second if this looks like a bloody nightmare to you. This is like a Rorschach test from hell. Just look at the graphs below, right? They look much nicer. Okay. Let's look at this last one here. Y is greater than 3/4 x. And x plus 3y is less than 0. Right? So I can graph each of these once again. This y is greater than 3/4 x is in y equals mx plus b format, where b is 0. So I go through that origin. And I have a slope of 3/4, so up 1, 2, 3, and over 1, 2, 3, 4. I have a dotted line. And I can't check 0, 0 because I go through it. So I'm going to check 1, 0. X is 1, y is 0. I'm just going to check that guy. If x is 1 and y is 0, that gives me 0 is greater than, because my y is 0, 3/4 times x is 1, so just 3/4. But that's false, right? 0 is not greater than 3/4. So my solution area is somewhere up here for now. If If I graph the other one, this one also goes through 0, 0, as indicated by the fact that both of my intercepts would be 0. So I could actually write this guy as, if I subtract x from both sides, let's look at the boundary. I would go x plus 3y equals 0 is my boundary. Subtract x from both sides gives me 3y equals negative x. And if I divide both sides by 3, this gives me y equals negative 1/3 x. That's easy enough to graph. It's also now in slope-intercept form where I go through 0 and slope of negative 1/3. So I go through 0, I have a slope of negative 1/3, so down 1 over 1, 2, 3. This is a dotted line also. This is where it gets really hard to tell what my dotted lines are versus the shade. So that's my dotted line right there that I just drew, and I just need to test. I can test 1, 0 again if I want to, so I will. X is 1, y is 0. Is that less than 0? That's not true, that's false. So it's not above this line where this point is, but now it's below it, and therefore our solution is this double shaded triangular region to the left again. And again, this graph, I'm looking at the screen here, looks like something some kindergarten class drew. Looks terrible. Look down below, this happens to be the last example on the bottom. And again, it's drawn much more beautifully by a computer than a marker. So, that's good, I think, here. I will see you guys for the next chapter.